and then we have at most 10 minutes for discussion. We start with Anna Isabel. She gives a presentation. It is a common work with others and about generalization processes and experience using Expressor with primary school children. So you will explain what it means.
Okay, thank you. Okay, I'm actually presenting on behalf of Cristianne. She was supposed to come, but then last minute we all got our grants cut off because of severe economic problems in my country, in Mexico. So I already had the plane ticket, so I was still coming, fortunately. Even though I have to pay for it. But. Okay, so her talk is called Generalization Processes, and you already read it, so I'm not going to read it again. So this is about early algebra in a Mexican primary school. And in the Mexican, how many of you are familiar with early algebra? Okay.
Yes.
Okay, good. So in the Mexican curriculum, the teaching and learning, I don't know what it's like in other countries, but the teaching and, sorry about the spelling mistake, the teaching and learning of algebra starts in 7th and 8th grade because it is argued that it is very difficult mathematical content, so therefore it's not available. It shouldn't be available to early ages. That's the assumption. But early algebra does focus on algebraic thinking that bridges arithmetic ideas and patterns with fundamental algebraic ideas such as the idea of unknown, or variable, function, equations, inequalities, etc. And when you do early algebra, you focus on the thinking processes that lead to algebraic ideas, even though they are not totally finished or are not completely expressed in formal algebraic language. And there's a lot of literature on early algebra. One route is to do proportional numerical and geometrical reasoning, and another is generalization processes, and we're going to focus on the second one. And Burnett and colleagues, he give 4 approaches to the teaching and learning algebra through generalization processes. First, generalization of numerical and geometrical patterns, and modeling of mathematical situations and of concrete situations, the study of functional relationships, and the solution of problem equations. And the discovering patterns requires 3 processes. One is activities with numerical patterns, another is expressing rules that characterize particular numerical patterns by means of sentences involving students in making clarifications and precisions, and the third is promoting that students express rules in short form. So these 3 processes are the things that were used in the study I'm presenting. And so the study was a study for introducing early algebra in Mexican primary schools by designing and implementing sequences of activities with a software Expressor. How many of you know of Expressor? Okay, good, because I'm going to present. In order to generate early algebraic thinking, specifically generalization, in primary school students of grades 5 and 6. That would be ages 10, 11, more or less. So Expressor is a constructionist microworld. It was developed at London Knowledge. It's a free Java-based software, and it was part of a project that they had in England, also with colleagues from, I think, Greece. And it seeks to provide students with a model for generalization that could be used as a precursor to introducing algebra. And it follows Pappert's, sorry, it's very small, maybe you can't read very well. It follows Pappert's constructionist paradigm because it provides several approaches for students to be able to construct their own mathematical models. In Expressor, students can build patterns of figures, of color square tiles, and express the rules underlying them. And they can work in a numeric, geometric, and programming environment and make use of patterns or regularities correspondingly to their inputs when they create a program and make sense of what they are doing when they validate their prediction. That is, children can construct these patterns of tiles and colors and encapsulate them in the form of blocks or shapes that they can repeatedly reproduce by giving rules for shifting the block in the horizontal and vertical directions, as well as for how many times they repeat the block. So I'm going to, let's see if this works. This is a video. It's 4 minutes, but I think I have time. Let's see if it works. And if it doesn't, I'll go out. Maybe I'll try to run it outside of the PowerPoint. It's just an introduction to expressors, so you get an idea what it's like.
These are various activities students' classrooms. For this tutorial, you will choose the activity, build your own model with no help. Let's open it. Adjust the construction area and the windows as you like. You can place tiles onto the construction area by clicking on the tile generator, then dragging and dropping the tiles where you like. Let's build a flower like this. Then you can group tiles to make a building block. Click on the highlighted tiles and select Make a Building Block. Now you can make a pattern. Type numbers in the number generator and drag and drop them to replace the question marks. Then choose how many repetitions of the building block you want and replace the last question mark. Notice that what you do with the construction area is mirrored in the general model. Your pattern is not colored. This is because you have not answered the question, how many tiles? There are 5 yellow tiles, so you Hooray, it worked. You can also scan numbers. Notice that in the general model, you can see the random values assigned to the unlocked number. Now you try to build a model like this one.
just to give you a glimpse of, and it's built explicitly for expressing algebraic concepts, like
you see, what is a multiplication, or which operation was done?
I was paying too much attention to. You want to see? I can put it. Multiplication, yes.
So, how many times? Okay.
So you're multiplying the pattern, okay? Oh, I can't see my mouse. Okay, so in our study, we had 30 students from a public primary school in the fifth and sixth years of elementary school. So these are 10 and 11-year-olds in Mexico City. So before working with Expressor, we had children do a questionnaire that aimed at exploring their ability, strategies, and difficulties in the identification of geometric and numerical sequences, as well as if they were able to understand the rule for constructing sequences in several ways. And these are just a glimpse of the questionnaire. And so there were 8 questions. Some had focused on arithmetic increasing and decreasing sequences. The second on comparing the growth of an arithmetic sequence, concomitant variation, linear variation, y equals 2x plus 1, the exponential variation from an arithmetic sequence, stating and solving an equation such as x plus x over 3 equals 1200. And so those were the questions in the questionnaire. And the questionnaire revealed that most of the students were acquainted with numerical increasing and decreasing sequences, but they did not continue sequences through the negative values. That they were able to give a rule on the number of sticks. If we ask them how many sticks you need to, there's a question on that. Needed for a given number of triangles, so they had to build with like sticks a triangle. At different degrees of generality, answers such as count the number of sticks, there are multiple, use a 3 times table, or for 4 I need 12, show that some students were in transit from additive to multiplicative thinking. And then the inversion of a particular item in the series presented some difficulties, even though it reduces to a division without remainder, the following transcript is not included in the PowerPoint, I just realized. I just got the PowerPoint this morning, so I didn't have much time to look at it, sorry. So the second stage of the study focused on a didactic sequence on generalization processes that was structured using worksheets to be done with Expressor. And so children worked in pairs with Expressor and were asked to draw designs that were in the worksheets. And there were 2 activities. The first one was called My First Pattern with Expressor. And here children were asked to build a simple block to reproduce a pattern shown in the worksheet. And they had to record the results from the My World window. If you remember, Expressor had 2 windows. There was on one side and then on the other. And they had to record their results on the worksheet. So here's a glimpse of the questions. And they're all in Spanish here, but I can't read here, it's too small. So group your tiles by dragging dragging them into the red rectangle, and so forth. So then they had to build patterns such as these. And so I can't, it's too small here, I can't read. Okay, I don't know how to do this. And so what happened was that the students became familiar with building to the right, or M down, or which, these, by the way, is a notation that is used in the expressor world. So, or, you know, N times exclamation point, or to say things like moving the blocks, N places right, N places down, yields a pattern. For left and upward shiftings, they use negative numbers, which they hadn't used in the initial questionnaire. So this showed that there was some improvement, some development of algebraic ideas. The second activity was working in the general world. So the first one was working in my world. This is generalizing. And I'm going to try to see if I can show you both this. Let's see if I go like that. And then I can read it from the... So here in this activity, it says, in this activity we will show you how to build a rule that will allow us to color the pattern in the general world of expressor. So build a pattern like the one shown in this figure. Its construction block was repeated 4 times. Color the pattern indicating to expressor the number total of mosaics that are necessary. What happens to the pattern if you modify your data? For example, if instead of repeating the block 4 times, you repeat it 5 times. Use expressor to fill out a table such as the one that is shown down below. I know you cannot see, sorry about that. Remember you must, well, this is technical, just release the block to see it easily. So how many times do you repeat the number, the block? So in the table it says 3, 5, 2, 0, 7, 9. Number of tiles, it's already filled in the tiles, so it's 12, 12, 6, 0, 21, 26. And the question is the pattern colored? So those are the things that they have to answer. And then in the next question, which you cannot see because it's cut down, maybe if I don't know if I hide one of these bars, maybe you can see it. Okay, yeah, a little bit. I'm just trying to do both things simultaneously, so it's a bit hard. It has, instead of, the last thing is just asking whether the pattern is colored. So you have a similar table, like the one you had, oh, no, I can't. Sorry, I cannot show you. So you have a similar table to the one you had before. I'm going backwards, aren't I? There, like this one. But the last table is filled. The last, not the column, row. The last row is filled with yes, yes, yes. And so you have a number of times of that the block is repeated, and then the student has to fill out how many tiles. So those are the kinds of activities that were given in the so now I'm going to try to go back to this. Let's see if this goes better. So some of the things that the conclusions from the study were that the early activities in both, this combined both the worksheets using paper and pencil and the expressor. And that the expressor software is a powerful tool for initiating in algebraic symbolization and for developing generalization related ideas. However, the key point in using the software is to take advantage of its property of integrating the numerical and geometrical context within a structured didactical sequence guided by the teacher, or facilitated, we would say here, that combines activities and materials in 2 contexts, paper and pencil and expressor. So I don't think I can answer presenting for her because she couldn't come to the conference. So if you have any questions, please email her. Her email is in the paper, and I did my best at trying to present. Sorry if it was a bit confusing. I didn't have time to actually she sent me the PowerPoint when I was already traveling, and I didn't have very good access to email, so I only downloaded it last night. So.
Thank you. Thank you, Anna. And we can have a discussion anyway. We don't need to ask questions. Yes, we can discuss what we have heard. I think these generalization processes, it's a good way. I think it's a usual way how to learn. You have first some special cases and then generalize. I think this is a way of learning, isn't it?
Yes, I
Yes,
think
you don't have to answer. It was a question to the auditorium.
That's actually the session before lunch was talking about just those types of things, really, the maths session.
Yes.
And about taking things that we do from our experience, do we then strip off the experience and then hold the knowledge? Or is actually that experience an integral part and we keep it? Do we put the
Process.
So what I'll do is
But
I'll
what-
show you.
But what was the first one? It was one of your first slides in the presentation.
You mean the worksheets
No, not the worksheet. The presentation.
in the presentation?
This was from Richard Noss and another proposed a different approach.
Oh, you mean the video?
No, the two approaches. And the second one was generalization process. And
Oh, the roots.
the roots, yes?
Yes, this.
Proportional, numerical, and geometric reasoning. It's because of my side. I thought this is similar, the approaches. Not so far away. This is what I thought during the presentation.
It's supposed to be the second one, is that right?
Because the first one is also concrete examples.
Yes, I actually believe it
Then you have to
integrates both of
generalize
them.
it.
I actually think it integrates both routes. It's using geometric reasoning with the tiles. It's using numerical because you have to count. It's integrating both routes in one sequence of activities.
Okay. So, if you have further comments? No, thank you, Anna, again.